Two examples of how this house fire could have occurred is 1. Too many power strips connected to one another. The fuse in a house usually let the power strips run hot enough to ignite the fire. This is because the wires inside the power strips are smaller than the ones in the socket. Smaller wires will lead to more heat, and you can easily overload the power strip. 2. A switcher with a too low IP level on a high moisture area. Assembling a switcher with a too low IP level on, say, the bathroom is extremely dangerous because it might lead to a short circuit inside the switcher. The moisture will intrude the switcher and can generate a connection between N and L.
An incorrect connection in your house will in most cases lead to fire. An accident like this can happen if one incorrectly connects an electrical appliance whereas the L and N connect to each other, which then leads to a short circuit. During a short circuit, the resistance will be around 1 ohm, which means there will be no current limitation. This will lead to an extreme heat inside the wires, and the copper will instantaneously melt and might vaporize, igniting everything around. Here's an example of a short circuit. The best way to avoid a short circuit is using the insulation tester to find out whether there is any connection between the wires.
This is an isolation tester, made to measure the isolation in wires and other electrical devices. How to measure isolation with the isolation tester. First off, put the black wire in the common input of the isolation tester. Make sure it always stays there, as you'll never have to remove it. Now, the red one is a little bit trickier, because you'll have to replace it whenever you need to switch between insulation measurements and resistance measurements. In this case, you'll need to put the red wire where it says insulation. Then, switch the switcher clockwise to where it says 500 volts. If everything is as it should be, you'll get the measurements 550 megaohms.